All right, so we'll be kicking off. Yeah, so good morning, good afternoon, good evening, good day to everyone joining us and listening to this. Now, today we'll be looking at a very interesting topic, how to automatically create a star schema in Power Query. And we have the opportunity to have a Power BI guru to take us on this journey. His name is Sam Fischer. He'll be taking us on how to leverage Power Query to automatically create a star schema, something different from the conventional method of creating relationships in the Power BI desktop model view. So this session is brought to us by UrBizEdge in collaboration with MHS Analytics. And if you don't know, we've been running this since 2020, since the COVID era. Although it has not been easy, but it has been very rewarding for both the audience and also the company. So let's about UrBizEdge. So we train individuals, we train corporate organizations, we train groups of people on Microsoft Excel, Power BI, and also financial modeling. So in case you have anyone who wants to take a training, or you have a company, or you have a group of people who are interested in taking one of these trainings, you can kindly refer us. I can tell you we are like the very best bet you have out there. So we also have online courses for those who will not be available to take the training and would like to take the training at a self-paced method. So we have online courses ranging from Power BI courses to Excel, financial modeling, and you can also register at class.urbizedge.com. I'll be dropping that link in the comment section soon. And our sister company in Canada, for those in North America, I would also like to take our training. We have a sister company in Canada named MHS Analytics. Just the same thing we do here in Nigeria. We do the same thing here in Canada in our company, MHS Analytics. So it's all about our speaker. So his name is Sam Fischer. He's a principal consultant at Revenite, a Melbourne-based company in Australia. And he's a self-described Power BI guru, and he manages a business intelligence center of excellence team. Sam is a Microsoft certified data analyst and also a Microsoft certified trainer. He has also completed the Microsoft professional program in data science, and he loves to apply his characteristic curiosity to solving interesting and complex problems. He is dedicated to knowledge sharing by coaching and mentoring others. And he also contributes to the Power BI community by sharing insights and techniques through his blog, Apex Insights. And this can be accessed through the site, apexinsights.net. I'll be dropping the link also in the comment section. And if you're looking to connecting with Sam, I'll be dropping his LinkedIn link also, which is going to be shared in the team chat. So not just to waste too much of our time, so I'll hand over to Sam so he can just feed us for the day. So Sam, over to you.
Yeah. Great, thanks for that, Akeem. And I'm just sharing my screen on this end, and I'll say as well, I appreciate you guys moving the typical timing for your session around just for me, because I know that over in Melbourne with the time difference, I think it's the usual time you run this session, it would be about 4 a.m. in Melbourne, so it's only 8 p.m. on Sunday at the moment, so it's a bit more manageable. So thanks for that. Great. So as we mentioned before, this session is all around how you can create a star schema automatically within Power Query, because it's not always straightforward as to how you can actually do that. So I'll take you through how to do that in this session. So I might skip over some of the introductory stuff because we've just gone through that. And we can get right into the agenda for this session. So for this session, we're going to start out with learning a little bit about flat files. What are they? When might we be dealing with them in practice? And how do they differ from, say, a star schema if you're building that out? As a bit of a spoiler, we're going to find that star schema is usually better to work with if you're not already across that. So in order to get from that scenario where you may have a flat file and you want to translate into a star schema, we're going to go through a few techniques as to how you can do that. So the first one's going to be a more manual technique as to how you can use staged queries within Power Query for that. And the second technique is going to be with an automated, more metadata-driven approach that's also going to be within Power Query. Now, just before we keep going, I know, Michael, you just mentioned in the chat around a bit of an echo. What I can do, just give me a moment, and I might swap some headphones around just to see, because it could be my Bluetooth headphones. So just give me a moment. Where are we? Is that coming through for everyone on your end? Just maybe pop a thumbs up for the audio.
Sounds good from my end.
Yep, perfect. All right. So that's the agenda for this session. So I'm also going to mention a few assumptions that I'll have for everyone here in the audience. So I'll assume that everyone attending this talk, you're familiar with Power BI Desktop and you're familiar with Power Query within Power BI Desktop. I'll assume that you fit into either the category of a beginner, intermediate, or advanced user here, because this talk has something to cater to all those levels. I'll point out that if you're a beginner to this, there may be some more advanced content in the end. Don't feel too disheartened by any of that. That's more catered to the advanced users. And for the advanced users, there might be a bit of a refresher content at the start. So just bear in mind that it will ramp up as the session goes along. I'll assume that you may have heard of star schemas before, at the very least from the title of the talk, but it's not entirely essential coming into this session. I'll assume that you can handle a fairly demo-heavy session because we're mainly going to be doing demos. And I'll assume that you'll rate this session 10 out of 10. Okay, so flat files. So when we talk about flat files, really what we're referring to is if you've got, rather than a well-modeled database, you might just have a single file with all your data dumped into a single table. And there's plenty of scenarios in practice where you may deal with this scenario. And I know that the ideal situation that you'd face with working with Power BI is you've got a data warehouse or maybe a lake house that you're connecting up to directly. You've had a data engineer upstream that might have extracted that data from source systems, transformed and loaded it into that warehouse structure, and then you're just basically visualizing on top of that. You may need to do some extra transforms to put things in the right structure that you want them, but most of that, I guess, heavy lifting is already done for you. That's the expectation, that's the ideal scenario, but the reality working with data is often a bit more complicated because data can exist in a lot of different places, and we don't always have the luxury of someone upstream preparing that for us. So we may have some of our data sitting with the business where business users maintain manual spreadsheets. We may have data sitting with other external providers or third-party vendors. And oftentimes, if you've got another vendor that you're working with that's storing your data, they're not always happy to give you, say, direct database access. It might be that your data is sitting in the same database with some of their other customers, so they want to protect their other customers. It may be that they want to also protect their IP for some of the information they've got within the database. So when they're providing you access to that data for your own needs, you may get it more in the form of extracts. You may have to get out of like a web interface where you might be building out a query so that you can pull like a CSV extract from an online portal. So you may be getting data from that means as well, or they may expose it via, say, an API. So you could be running automated processes to get extracts on a daily basis out of that API. It may come in more of a document format, like a JSON structure, but you can see that we've got all these different ways where you may get a single dump of all of our data into a single file, a flat file usually. And we've got to work out how to work with this so we can actually build some insights out of it. So when we don't have the luxury of a data warehouse, that's okay, because we can use tools at our disposal like Power Query, where we can ingest those flat files, convert that into a star schema that we typically have within the warehouse. But if we don't, we can build it ourselves with Power Query, and then we can visualize that in Power BI. All right. So with that, we can jump into our demos. So what I'll do is I'll jump to our first demo file, and that's one of our last ones. Let me jump to the first one, which is this flat file here. Okay. So in this first demo, I've got a single data file already loaded into my Power BI desktop file here. If I look at the model view, it actually loads up. I'll be able to see that there's only a single table within the model view here. I've called this sales flat table. And if we look at the table view, I'll be able to get a better view of this. So this individual table, this represents sales transactions that's come from the Contoso data set. For those who aren't aware, it's a Microsoft training data set for retail transactions for a large fictional organization called Contoso, who have sites all across the world where they sell their products. So for this data set, we've got quite a number of sales transactions over the last few years. We've got about 1.5 million records within this data set. And we've got a number of columns to describe what's going on with the sales transaction. So we've got a unique sales key for each of the line items within our sales. We've got a date key, which is when the sale took place. We've got a number of different measure columns that we could build DAX measures off of. So unit cost for the item sold, unit price, returns, discounts, anything applied at the transaction time, and then the total cost and the sales amount. But on top of that as well, we've got a lot of other more descriptive columns here. So for each purchase, we can see how was the purchase made, via what channel. So was that via a catalog, via the online store, a reseller, or directly in the brick and mortar store? We can see information about the store itself, if it was bought in a brick and mortar store, even some things that aren't as relevant, like employee counts and selling size area for the stores. We can see information about the geographies, so what continent and what country were the sales made from. And we can even see things like the promotion. So was there a promotion applied when the sale took place? For these records, there wasn't exactly a discount, but there's a whole series of different promotions that took place over the 2-year period where our sales took place. And we've also got information about the products, the product name, description, manufacturer. You can see a lot of these were made in-house by Contoso, but there's also other manufacturers that they sell. And then we've got information about the date of the sale. So we can see the month name, day of week, year, quarter of year. So we've got a lot of fields here, right? Now, all this being in the one table, it's good if we want to just scroll around. It's good if we're working in Excel. If we want to just filter and look at this view, it's okay. But we do face some kind of challenges here, and we'll see this a little bit as we start to build out some visuals just to see the challenges. So one of the first things is when we go to the data view here, we're going to be dragging fields from this data pane on the right-hand side. And it does become a bit tricky to work out exactly where the fields that we might want are when they're formatted in this way, where it's just all in one table. So for example, in this list, I can see that my promotion start date relating to my promotions for the sale is right next to my quarter of year column, more about the dates. And that's right next to the region country name, or the country that the sale took place in. So it's already going to be a bit tricky for me to drag and drop and find the right fields there, because they're kind of conceptually in a bit of a jumble, even though they're alphabetized. So that's one of the things that you'll note when you're working with a flat file. But we can still build a number of visuals in here to get some insights, right? So I can start out by building a fairly simple line chart. Let's say I want to look at my sales by date, right? So if I wanted to do that, I'd need to find my date column, which is with this date key, can pop it in the x-axis well. And then I might want to know about the sales, so I can look for the column for sales amount. And I'm just going to use this as an implicit measure. I'm not too worried about building a formal DAX measure, because the main focus of this presentation is more about Power Query. And I can see what the sales are trending like over most of a 2-year period. So I can see that the sales started fairly low in January, and in fact, this is starting at 6 million, which is not too shabby at all. I might actually change this to a stack column chart for the moment, so you can see that there's actually quite a number of sales still happening at the start of the year, but it's probably the quietest part of the year, just after the Christmas period. It ramps up in February, but then the sales go back down in March. and they've ramping up around Easter and staying pretty high, ramping up for the most part in the lead up to the Christmas period. And then once people are all shopped out and we're back to January the following year, we get the sales kind of going lower again. So this is a pretty standard kind of seasonality you might see in a retail business here. And then swapping this back to a line chart, I might want to do some additional analysis on top of this, which I can do with a flat file when I've got this loaded into Power BI. So I might want to look at my sales by particular stores. So I can bring in a slicer. I'll just resize this a little bit. And then for this slicer, I can bring in, say, my store name. So where's that? That's going to be here on the store name. And I can use this slicer to filter my sales down to see what was the sales like for each particular store. So unsurprisingly for Albany, one of the highest periods was around, again, the Christmas period. I can look at these other ones and do some similar analysis and drill into this further if I want. I can also look at this with other fields. So I could slice this instead by product. So if I bring product into this other slicer, I can see I've got the full list of all my products that I'm selling. And I can slice this to see how, say, these M300 Azure cameras sold over time, these grey 300 cameras sold, or even these 200 silver ones. Now, the more observant of you may have noticed that when I selected this M200 silver product, I actually had a bit of a change to this store name slicer. So when I select and deselect it, you can see that my Albany store actually disappears as I select the silver one. And then similarly, if I want to work out what's going on, I can see that the Albany store, it actually, when I have that selected, it omits that silver camera there. And if you've used Power BI before, you probably know that the reason for that, or the way that you can interpret that, is that at Albany, there were no sales of that silver M200 camera. And it may be because it's not a particularly fast-moving product at that store. Maybe they've had that product sitting on the shelves for a couple of years, no one's bought it. It may be because they don't stock the product at all. But whatever that reason is, when we've structured things in a flat file, we often get this kind of behavior. And it can become a bit of a challenge for your end users, because oftentimes you might have more than just the two slices selected. You may have like 3 or 4 along the page or even more. And oftentimes your business users may have a few slicer selections made in other slices, where they'll then look at, say, the products and they'll say, oh, some of these products are missing. Or on the other side, they may have one particular product here and they're saying, oh, the Albany store is missing. What's going on there? And they might lodge a support ticket. You've got to process that. And as a BI team, you've got to be able to explain that to the business and help them to understand and work through the data literacy piece around that. And that can be, at scale, that can be a bit of a challenge. So there are ways to get around that, even when you're working with a flat file. So you can, for these slices, you can go into the format pane, you can click on edit interactions, and you can set it so these two slices don't interact with each other. So then they're not going to cross-filter each other. But there are better ways to do things. And those are some of the reasons where a star schema comes in to make things a little better. So now let's jump to our second demo file, which is named star schema, unsurprisingly. And we can start by, for this file, jumping into the model view here. So in the model view, this is a model that describes the exact same data that we had in that flat file, but just structured in a slightly different way. So we've now got multiple different tables loaded into our Power BI data set. And there's 2 different flavors of them here. If you've never dealt with a star schema before, a bit of an intro here is that you've got 2 different flavors of tables here. You've got a fact table in the middle, and a fact table basically describes your sales transactions, or more generally, it describes any business activities that you may be interested in analyzing. So it's really just an event that happened. And then for the dimension tables that are all surrounding it, these are more descriptive attributes to describe that event that happened. And you can think of these oftentimes as the who, what, where, why, and how to describe the fact. So whenever we have a sales transaction, we have a when, which is described by this calendar table. We have a where, which is the store that it took place in. We have a what, which is the product here. That was the what product was sold. We have a promotion, which you could maybe even think of as the why. Why was the sale made? It was prompted by this promotion. And the how, which is the channel. Was it a brick and mortar store? Was it purchased online? And part of the reason why we call this a star schema is because we have our facts and dimensions related in this one-to-many fashion, where all of our dimensions are on the one side of the relationship and they relate to the fact on the many side. And in like an entity relationship diagram, you would often see the many side represented by some crow's feet, and it makes the fact table in the middle look like a bit like a star, hence the term star schema there. So that's the structure of this in the model view. If we jump to the table view, we'll be able to see when this loads up that we've got a number of different tables represented on the right-hand side here. So this already becomes a bit easier to navigate. If I look at my fact sales table, this has, again, all my sales transactions in here. We've got that same 1.5 million sales transactions that we had in a flat file. But in terms of our columns, things are a little different. So we've got our sales key still and our date key, but we've got these new key fields here. So channel key, store key, product key, promotion key. Now, these are all foreign keys that are going to relate to the dimension tables that we've built out otherwise. And then the remaining columns within this fact table, these are all numerical columns, which we can use to make measures off of here as well. But you can see it's a much skinnier table now, this fact sales table, because all of our other more descriptive attributes, they're all contained in the dimensions. So our calendar dimension, this has one unique record per date in our data set. We can see at the channel, it's fairly minimal, but it's just got the 4 records for one of the channels. Products, this has one unique record per product, and similarly for promotion and store there. So this already makes things a little easier because we know that things are a bit more conceptually grouped within each of these tables. So when we're going to drag and drop visuals, this already makes things a lot easier. So that's one advantage that we're going to have with the star schema. But look, we can do some similar analysis and we can see, are we going to have similar issues with that slicer? So let's find out. So we can very quickly recreate these visuals where I'm just going to add in the calendar table, my date key in the x-axis. I can, from the fact sales table, I can grab the sales amount field, bring that into the y-axis. We can see that same familiar chart from before. We can bring in a slicer for our store name. So I can go into dim store, bring in store name here. And then I can bring in final slicer for our product name as well. So if I go to product, I can bring in the product name as well. So now that I've built things out in a star schema, if I do that same kind of analysis where I want to look at individual products or stores, I can select, say, the Albany store, and I can see that this product list is unchanged. So that's going to avoid that confusion for the end users already without having to do any manual changes to the report with like editing interactions. And then if we select some different products, we can see the sales for these products at Albany. But if I select the M200 silver camera, which we already knew had nothing or wasn't even an option in the flat file, we can see that the visual actually blanks out. So that blanking out, you can interpret, if you like, as there being no sales, but really it's more of a null rather than a $0 spent. So if I jump to the model view here in a star schema, what's actually happening here is when I say take a slicer selection in the store dimension, what that does in practice is that selects a single record related to the Albany store in the store dimension table. And then through this relationship, through this filtering direction, this arrow that points down towards the fact sales table, that's going to propagate that filter down to just the sales transactions relating to the sales of the products in Albany. And that's fine. It filters the sales table. What it doesn't do is it doesn't send that filter back up to the product table, because this directional arrow here for the filtering direction, this isn't a bi-directional arrow. It doesn't go both ways. It only goes back down to the fact table. So that filter isn't going back up to product. But then when I select my M200 silver camera in the product table, that's sending a second filter down to the fact sales table. And because there's no sales for Albany store and the silver camera at the same time, it effectively wipes out all the records within that fact sales table. And that's why we get this blank visual here. Now, there are visual level tricks that you can use as well to actually explain this a little better. You can have messages popping up saying no sales found or something like that. You can even author your DAX measures in a way that where you have these kinds of blanks or these kind of scenarios, you can return $0. So it's a bit more it's intuitive in a different way for your end users, but at the very least, you're not going to have that same issue of people saying, oh, why are my products missing from that slicer there? So those are some more kind of front-end surface level reasons why you might want to go with a star schema or a flat file. But there's another really key reason, which is around the performance and the compression of the files there. So to show you what I mean, I'll jump back to the flat file table here, and we want to actually have a look at what's the size of this data set, how much space is it taking up. So what I can do is I can jump to my external tools here. I'm going to click on this DAX Studio icon here. If you haven't used DAX Studio before, it's a very useful tool to be able to understand your model in a bit more detail. And now that that's loaded up, what I can do is I can click on the Advanced tab within DAX Studio, and I can click on this View Metrics button. And when I click on that, it's going to run some analysis over the data set. The key thing that I'm most interested in is this summary here. So this summary for this flat file, PBIX file, tells me that I've got 38 columns loaded into my data set, and that's taking up in memory about 36 megabytes worth of space. So that's important to note, 36 megs. Now, if I compare that to my star schema and go through that same exercise where I go to external tools, click on DAX Studio, and run that same analysis, and I'll see how much space this star schema file takes up, because we have the same 1.5 million sales transactions here. But if I view the metrics and go to the summary here, I can see that it's actually got more columns within there. It's got my 6 tables taking up 54 columns, probably due to those extra keys within the model. But even though it's got more columns there, it's only taking up 26 megabytes. So I've gone from 36 to 26. I've probably saved about 30% of the data model size. But if you're talking about a large model that's, many hundreds of megabytes or even gigabytes, that saving can be immense. And it also translates into the performance of your visuals when you're slicing and dicing on your report page. So the more lean your model is in terms of the total size, in general, it's going to often translate to a performance benefit as well when you're slicing and dicing on your report page. So that's another key reason why structuring things in the star schema is usually the way to go. So let's say you're in the scenario where you don't actually have that star schema yet. So you've been provided with flat files and you need to get from a flat file into a star schema. So how do you actually do that in Power BI? So that's where we can jump to our next demo, where we'll go through how you can actually build out that star schema from a flat file in Power Query. So to kick us off, I've got another file loaded where I've got that same flat table loaded in here. And I'll go to transform data. I've already got Power Query open, and I've got that file loaded in. I'm filtering this down to just the first 1,000 rows for the purpose of the demo, just to make the transformations run a bit faster. But we can still apply this to the full data set if we want. Let me just zoom in a little bit so it's a bit easier to see. Okay, so if we want to build out our star schema, the first thing that we're going to do is we're going to start by building out our dimensions here from this flat table. So what I might do is I'm going to take this sales flat table that's sitting in this source queries folder, and I'm going to reference that. So what that's going to do is that's going to create a second query where that's going to inherit all the transformations that happen upstream in the one it references. Then I can do some extra transformations on top of that. So this first one, I'm going to move into the staging queries, and the first dimension that I'm going to make, I might make the calendar dimension. So I'll call this dim calendar, and I'll call this dim calendar staging, because there's a bit of work I've got to do before I have my full dimension ready. So to build out my dimension, the first thing I'm going to do is I'm going to identify all the fields that are conceptually related to date that are going to sit within my date dimension in the end product. So we know that that's our date key, and then that's also going to be towards the end here. We've got the month name, the day of week, the year. I'm just multi-selecting these by holding down Control on my keyboard while I select these columns. So I've got quarter of year, month of year, and day of month. So these are all the fields that I'm going to want in my calendar dimension. From here, I'm going to select Transform in the top ribbon. I'm going to click on Group By. And then when I group by, instead of using count rows, I'm going to use this all rows operation. And I might call the resulting column, I'll call that all rows as well. Let's see what we get. Okay, so I'll just zoom out a little bit so we can see that in this table here, and I can just sort this as well, I can see that I've got one unique record per date here, which is what I'm going to need as the granularity for my date dimension. Because I've only got the first 1,000 records in the data set, it's starting from April rather than from January, but this still demonstrates the idea that I've got this one unique record per date. And then in this all rows table, what I've got here is, if I select here and look at the preview of that table, this first record has all the sales transactions for that 1st of April date there. The same here for the 2nd of April. I can see these are all the transactions for the 2nd of April, 3rd of April, etc. So for the calendar dimension, this is all I'm going to need. So what I can do from here is I can reference the staging query, and I'm going to drag this resulting one into my loading queries. I'm going to retitle this as dim calendar. And then at this stage, I actually don't need this all rows. I'm going to need it in a moment, but to actually load up my calendar dimension, I don't need the all rows here. So I'm just going to remove that. And the resulting query here just has my date key, month name, day, week, all the fields I'm going to need in my date dimension. So this one's ready to go. This is ready to load into the model. But then I need to build out my other dimensions. So say I might want to build my product dimension next. So for my next dimension, what I'm going to do is I'm going to go back to this staging query. I'm going to right click and I'm going to reference this a second time. And I'm going to kind of fork these off into 2 separate paths. One where we're going to create the calendar dimension, and another one where we're going to build out our next dimension, which is going to be our product dimension. So I'll call this one dim product staging. And from here, what I'm going to do is, I know that I've already got my dim calendar ready to load up into the model. So I don't need any of these columns here anymore. So what I'm going to do is I'm going to select my all rows column. I can right click and I can just remove all the other columns within there. And this is going to leave me with this nested table that has grouped up all my transactions by date. And I need to re-expand this back out to the full grain of that flat table. So what I'm going to do is I'm going to just click on expand here. But now that I've expanded, I'm back to my original 38 columns here. And again, I don't need those calendar dimension dates, those columns there, because I've got them in this re-expanded one. So in fact, what I'll do is, instead of including that, let me just go through that again. But instead, I'm going to re-expand. I'm going to remove all these columns that relate to date. Now, I am still going to need my date key, because that's going to be my foreign key that I'm going to use to connect my eventual fact table back to that dimension there. So I'm going to keep that in here. Now I've re-expanded. I'm down to 32 columns. So I've already made things a little leaner as I've gone. And now I'm going to build out my product dimension. So now what I'm going to need to do is, just like before, instead of selecting the calendar dimension fields, I'm going to select the ones relating to product. So I'll select product name, description, all the way through to product category and subcategory. Just select all of those, and just as before, I'm going to go transform and group by. And then in my group by, I'll do that same all rows transformation that we did before to group things with one individual row for all the transactions per product. So you can see here for this M200 green printer, we only had 2 sales across the data set, and that's been grouped up here as well. So I've pretty much built out my product dimension, except I do have one little challenge I've got to contend with. And that's that I need to make sure I have a primary key that I know is going to be unique for all of my products. Now, I could assume that the product name is unique, but I don't have any guarantees of that. Like, I might have 2 different manufacturers who have different products that have the same name. So that's going to cause a bit of a problem for me if that happens. So what I'm going to do, just as a bit of an insurance policy, is I'm going to create a new primary key, a surrogate primary key. And I can do that with going add column in the top ribbon, and I can click on index column here. So once I've got things grouped up to the grain of 1 record per product, I can create this index, which I'm going to retitle this one here. Instead of calling it index, I'm going to give it a more useful name, which I could call product ID. So now I've got a unique product ID for every product here. Great, so now that I've built this out, I'm ready to create my product dimension because I've got everything I need. So just like before with the calendar dimension, going to loading queries, I can do the same for my product dimension. I'll retitle this one. And again, all I need to do is just remove this all rows column. So I'll remove him there. And now I've got my product dimension ready to load in. And I can, again, if I want to build up my third dimension, I won't go through every single dimension, but what I would have to do is I'd have to, in this case, because I've created a new primary key for my products, I need to make sure that I'm retaining that as a foreign key for all of my sales transactions when I have my eventual fact table. So what I'm going to do is, instead of removing every column besides all rows, I'm going to also keep my product ID, and now I'm going to right click and remove other columns. And then once I've done that, or rather, sorry, I've gotten ahead of myself, because what I'm going to need to do is actually fork that off into another reference queries, because I don't want those changes to go down to my product dimension. So from this query, I'm going to select all rows and product ID. I'll remove other columns, and then I could re-expand this. And in this case, I would be removing all of my product related columns here. Click OK. Now I'm down to 26 columns, and I've got my product ID that I'm going to need. Yeah. So I could go through this exercise for my other 3 dimensions, but that's going to be probably a bit boring for the sake of this demo. So I can jump to another file where I've already done all that hard work here. So this is another file where I've got, zoom in just a little bit. I've got all of my dimensions ready to load in there, because I've gone through this same approach of creating another dimension by starting with it grouped up on the previous one, removing everything but the product ID, re-expanding, regrouping based on, in this case, my promotion dimension, and then adding that index for the promotion ID that I need to do. So I can go through that and do that for each of my dimensions to build out my dimension, my dimensions that I'm going to load into my model. And then once I've done all that, I'm ready to build out my fact. And that's actually probably once you've gone through this work, this is the end cap. That's the easiest bit to do. So all I need to do is, once I've built out my 5 dimensions, or however many I might have, which is going to look like this for the end of the dim channel query, all I'd need to do is, again, remove the attributes for this dimension, and I'll just be leaving my all rows and my ID for that one. Then I'm just going to re-expand, where in this case, if I look at what I've actually included, I've just removed that channel name here. So now, at this point, I've got my sales key, my date key, which I had from this date dimension. I've got all my unit cost, unit price, return amount, all those numerical columns, and then just my IDs that I can use to relate to my dimensions. And then this is pretty much just ready to load into my model. So I could go right click and reference, and that's what I've done to generate this fact sales table here. At this point, I've got everything that I need to load into my model. So to summarize this, because there's a bit of work involved here, but it's often good to go through a bit of a visual aid here. So I'll just walk you through this piece by piece. So how this staging queries approach we just went through works is that we've got our 3 types of queries. We've got our source queries, staging queries, and loading queries. And you can conceptually think of these as kind of relating to bronze, silver, gold within a medallion architecture, if you're more familiar with that these days. We start with our flat table as a source query. We reference that to build out our first staging query for our first dimension, and we basically just group that up to all the unique elements of that dimension. So we found in the first instance when we did this for all our unique dates. And then we'd have this all rows column here for the grouping. So that's all we need for our first staging dimension. And then we fork this off into 2 separate queries. We generate our dimension 1 that we're going to load into our model, where we just need to remove that all rows column there. And then we create another forked query where we can build out our second dimension. So for the second staging dimension, we're going to re-expand that back to the fact sales grain, but only after we've removed the attributes from that first dimension. Then we regroup that into our attributes or our entries for our second dimension there. And then for the product dimension, in that case, that's where we added in our surrogate key where we needed to for a product. So we can go through that again, where we're generating our second dimension. We can go through that for how many dimensions that we have, where we're doing this kind of grouping and re-expanding. It's almost accordion approach for our table. And then when we're ready to cap this off and build our fact table, we just need to re-expand that from the final dimension that we built, and then get that ready to load into the model. So that's how this technique works. It's fairly useful where you're dealing with just a flat table and you've only got Power Query at your disposal. Again, if you've got something a bit more performant that you could do earlier on in the piece, something like say, at the worst case, like a data flow, but even something like using Python, Spark, or any other tools like data pipelines to build these out, they can be options for you, but this gives you a way to go about that. One of the drawbacks I will admit with this technique, though, is that it is somewhat manual. You have to go through this for all of your dimensions, however many you have. And if you've got quite a wide flat table that you want to build this out on, it can be a bit cumbersome, and there's room for human error there. So I usually try to think of ways to take the human out of the equation and try and automate a bit of this. So that's where we're going to go to with our final demo, where we're going to see how can we take all this approach that we've just gone through, and how can we do this in an even easier way. So that's where we'll bring up our final file for this demo, where we're again starting with our flat table, just as before. But if I go to Power Query for this one, I've got only a couple of tables here that really matter for this one here. So I've got my flat table, which again, for the sake of transformation, is only 1,000 records. But then I've got another table that I've got ready to go here. And this is what I call model schema. So this model schema table, this is quite a small table in comparison. It's only got 38 rows, and it's got one row for every column in my flat table query. So this has my sales key, my date key, unit cost, all those familiar ones. But then I've got some extra attributes to describe those. So this is basically going to map onto what are all the entities that I want these columns to exist in my star schema. So I can see that my unit cost and unit price, they're going to live in the sales fact table. I can see that channel name is going to live in the channel dimension, store name in the store dimension. So it should be fairly intuitive in that regard. This is just mapping out what entities they belong in. And then I've got one final column here, this one that I've called existing primary key flag. Now, what this column does is this just identifies any columns that I can use as an existing primary key within there. So I know that my date key is one of those. I didn't have to generate a unique date ID for my calendar dimension because we could already use the date key for that. So I flagged that as true under existing primary key. But the rest of these are all false. Now, that's all there is to this more automated technique. I just need my data table, and I need this metadata control table to tell me what are all the dimension tables and what's the fact table that this is going to be realized as. So now all I have to do now is I've got this custom function here, which I'll walk you through, especially for the more advanced users in a moment, where all I need to do is select my flat table as my flat table source, select my model schema as my star schema metadata, and then I can just click invoke. With a single click, I've pretty much done automatically all the work that we just went through for that stage queries approach. So if I just move this invoked function into the output here, I can see that I've got an even smaller table, which has one record per table within my star schema. So I've got sales fact, calendar dimension, channel dimension, and the rest of them here. And then within this all rows column here, I've actually got grouped up. I look at the preview here. I've got grouped up all the records for each of those entities, my sales fact, my calendar dimension, etc. So I can see that I've got my sales key, unit cost, unit price, all those numerical columns. Then I've also got my date key and those surrogate keys that we went through and manually generated in the previous demo here. So if I want to get this ready to load into my data model, all I need to do is just right click, go add as new query, and I've got my sales fact here. And this is pretty much ready to go. And I will do the same for the rest of these. I could right click on my calendar, add as new query, go to my channel name, right click, add as new query, and I've got my channel dimension built out here as well. So it's a hell of a lot easier going through this more automated approach. So that's good to know. So to cap things off for more of our advanced users, if you're interested, the way that this function works, it's a bit involved, but I'll walk you through the ideas behind it. So you can see there's a fair few within the M code that describes that custom function. There's a fair few nested functions within here in order to get to the final output. So I can walk you through them with these explainer functions here, which replicate that logic. So just like with the manual stage queries approach, the first step with the process is to create all of our dimensions. So let's walk through the logic of how it does this. So let's say we're starting with building out our first dimension, our calendar dimension. What the function does is it starts with identifying which dimension you're talking about, and it filters down the model schema table down to just the records that refer to that calendar dimension, because that's going to be useful information for us. We're going to select just a list of the column names that are going to exist in that dimension, because we're going to need that list for later steps. And then the next block of steps, we're going to use that to identify the existing primary key, which is relevant for this calendar dimension here. So what we can do is, first of all, filter down that earlier dimension columns query down to just where there's an existing primary key flag. And we found that that is the case for this date key. And we've just got to identify the name of that, which we're going to use later. And then I've just got a bit of a data quality check here to verify that we have only got a single primary key flagged, because if we've got multiple columns flagged as the primary key, that could cause us a bit of grief. So we're just going to throw an error if there's more than one existing primary key flag for that dimension there. So if we found there was multiple, we'd be throwing an error here to give us a warning of what's going on. Now, the next block of steps is where we kind of go through that grouping and re-expand. So we'll go back to our flat table here. We're going to select, we're going to group by those dimension column names we identified in the earlier step. But then we're going to also add in our all rows column here. That all rows is just going to include, it's going to include everything besides our dimension column names, because again, we don't need those because we've already got them existing out here. Now we've got another data quality check here, which is to verify that our existing primary key is unique. And that's because there may be in the actual flat table, even though in our model schema, we may have specified that, yep, you can treat this column as the primary key. We just need to verify that the data actually reflects that. So that's what this uniqueness check does. It just checks the row counts for each of the different stages of the query and just verifies that they will match up. And then it's not as relevant for this calendar dimension, but if we're needing to generate a new surrogate key, that's what this step does here, where if there isn't an existing primary key, we're going to add an index column. So then finally, we're going to re-expand back to our flat table grain. So we're going to start out with a list of just our other columns, because we're going to need that list to generate that re-expanded one. We're going to expand everything out to just include those other columns that we just looked for. But then one of the challenges with getting to this point, though, is that if I scroll across here, I can see that for all my columns that aren't related to the calendar, I've actually got this ABC123 icon here, which kind of means that I've stripped away the data types for these columns there. So I need to restore those so that I don't lose anything along the way. So in order to do that, the final thing that I can do is I can go to my flat table. I can run this table.schema function. That's going to give me some information about the about all the fields within this table, this flat table query. So I can see all my data types for the original flat table. So I can take this list here and I can do a bit of Power Query magic to try and whip this into shape so that I can identify all those existing data types and I can reapply them by this transform column types transformation. So now when I scroll across, I can see that my store name has been restored to text type. I can see that my discount amount, total amount have been restored to decimals, discount quantity is an integer. And this gets me back to where I started here. So we can do this for all of our dimensions. Just to whip you through this quickly, we can also see, say if we want to do this for our product dimension, like we did manually, get rid of this from the IntelliSense, we can go through the same exercise for our product dimension. So we can see, again, we're going to filter down to just our product dimension fields. We can select the column names there. Now, we go through this same checks for the existing primary key, but we can see that we've filtered down and there's no existing primary key flagged for the product dimension. So That's not too much of a concern for us. We've seen that there's no existing primary key. And then we can just skip down to the next few steps where we can, again, group on all of our product dimension values. We don't need to check existence of the primary uniqueness of the existing primary key because there is no existing primary key. But then, because there isn't one, we're going to need to create one. So that's where this add index column finally comes back into it. So it's generated our product ID just like we did manually. And then this would be going through that same exercise where we're re-expanding. This time, we've re-expanded, we're including our product ID here. And then we're restoring our column data types as well. So we need to go through this and apply this, the logic of this sub function for the dimensions to all 5 of our dimensions here. So if I actually look at the function definition, how that gets realized is I've got the logic defined here that we just went through for a single dimension. But then what I need to do is I need to loop over that. So I've got this all dimensions function nested within it where it actually loops over. We've got this loop counter. We're going to loop over each of our dimensions here. And then how this works is we're going to apply this apply the logic that we've applied here. We're going to check if we've looped through everything to this point because we're going to go through this one by one for each dimension in that list. If we have got to the end, then we're just going to return the output. But if we haven't, we're going to recursively use that function again, which is what this little @ symbol is about. And we're going to kind of go one layer deeper and we're going to apply this for the next dimension. And that's so that we can collect those surrogate keys along the way as we go. So then to wrap all this up, the logic of the entire function goes that we start with our flat table here. We also have our model schema table here that we need to use. And then we start by building out our table that's going to be our output table, which has 1 record per entity within the star schema here. And we've got these column details grouped up because they're going to be useful to feed into the next few steps. We'll also extract out all of our dimensions because this is the list of dimensions that we're going to loop over in that recursive function. We're going to define, in this one, we're going to define the recursive function, and then we're going to apply it. So we're going to apply that function we just defined against the flat table using that schema. We're going to use the dimension list that we just defined earlier. We're going to loop over that for the entire count of how long the list is. Then we're going to just have a nominal starting point of 0 for that loop counter, so that's fine. So now that we've done that, and we've ran this function recursively, what that does is that stitches on all of our IDs here, doing that same group and re-expand and group and re-expand operation that we did manually earlier. And then the final thing to get to our final output, now that we've got the full flat table with all the surrogate keys that we're going to need, well, first of all, we'll finally identify what are the keys that we're going to need to make sure that we include in the fact table to act as foreign keys that we've just got as a list here. And then we've got our final output here. So our final output is just adding in a manual or a conditional column here for the all rows here. So how this final step works is to create this all rows column that's represented here. We've got 2 slightly different paths that we take, whether we're talking about a fact or a dimension. So if we're talking about a dimension, so any of these rows 2 through 6 in this query, we're going to start by attempting to select all the columns within the flat table that has all the keys, but we're only going to be selecting the ones that relate to that dimension with this column details column name. Then we're also going to add on the presumed surrogate key that might exist there because it follows this naming convention of the table name and then adding ID on the end. So we're going to attempt to do that, but that's not going to work for our calendar dimension because we didn't need to. So we've just got this try this one, but if that doesn't work, otherwise just return it without that ID column. So that's what happens for the calendar dimension. And then we just need to run a table.distinct to just give a unique record per record, unique records within the dimension there. So that's what this does here for the dimensions. But for the fact table, it's even easier because we don't need to do any of that that different logic, whether or not it has a surrogate key. We just start with a flat table that has all the keys within there, and then we just make sure that we've got the sales fact relevant columns there. Then we're also including the dimension keys so that we've got those to act as surrogate keys there. And that's how we build out this fact table here as well. So that's the whole approach that we deal with. So by automating that manual approach we've made things a lot easier. So I guess to wrap this one up, to wrap this session up, we've kind of gone through a starting point of understanding what are flat files, when might we encounter them, and how they differ from a star schema. We found that a star schema tends to perform a bit better. It tends to be a bit easier to work with. So we've gone through some approaches of how you can actually convert a flat file, if that's your starting point, how we can use Power Query to convert that into a star schema. So we first of all went through that manual approach where we group and re-expand those staging queries and then shed off each of our dimensions and our fact table to build out our model. But then we found there was an opportunity to automate this. So we've taken that same idea, that same logic from that manual approach, and we've built out this function so that all we need to do is a couple of clicks and we're able to easily generate all our entities within our star schema. So yeah, I hope you guys found that session enjoyable. But what I might do is I might hand back over to Hakeem just to facilitate any questions that you guys might have.
Okay, I think we have a question from Pranam G. It says, do we use Excel to map out the model schema and then import it into Power BI?
Yeah, I mean, that's a good question. So if you're building out this model schema table, so there's probably a couple of things you need to do. So the first thing is to conceptually map out, for each of these columns, what entity do they belong to. So you're going to have to put your data modeling hat on and just think about what one they're going to belong to. To actually build out this table, I pretty much just you can just manually type this out in Excel and you can just load this straight in. So that's how you could do it there as well, because you're going to need to manually define somewhere your definitions for what belongs in each of these star schema entities.
Thank you for the answer. Does anyone have any other question for Sam?
Yes, so another one around, we'll be sharing the file after the session. So absolutely, I've got as well built already available on GitHub. I'll just drag over my other screen. I've got all these files available publicly for you guys to have a play with if you like. So these are just sitting on my my GitHub here. This is all the files that we went through. It's even got the data file if you want to play with that. So I'll just I'll paste that into the chat now so that you guys can play with that. Now, I will also just briefly mention that this technique, it's not absolutely perfect, right? So it's fairly useful, but you are going to have drawbacks depending on different dimensions you might want to build. So say in an actual data warehouse, you may have some additional rows to account for referential integrity issues. So you may have, say if you've got late arriving data, you may have a sales transaction for a customer that you haven't got all the information for. So you may have like nominal, no customer information records or dummy records in the dimension that this technique won't necessarily have you covered for. And the other thing that I'll flag that you want to be careful of with this one is especially around building out date dimensions and calendar dimensions. So typically you would want to have a calendar dimension so you can do time intelligence within your model, so you can build out some time intelligence functions. But the challenge with that is you need to always make sure that to do that, your date dimension has a complete contiguous set of dates, so you don't have any gaps within the start date and the end date. So if you're building out in this way, and say you've got sales transactions that describe a business that doesn't operate on weekends, well, you're not going to have any sales on weekends, and hence when you run this approach, your calendar dimension isn't going to have weekends reflected in there. So that's not going to make for a very appropriate calendar dimension to use within your model for the sake of time intelligence. So that's another thing to be wary of. I haven't gone through, I could augment this function to also address those scenarios. I just haven't really bothered to because it's more of a teaching tool. But that's something to be mindful of as well. Cool. And I can see Pranam's also got another question. Do you have any tips or books on how to develop the star schema model? That's a good question as well. I would probably say there are a couple of really useful books for that. So there is the data model, the Data Warehouse Toolkit by Ralph Kimball and the Kimball Group. So that's a very useful resource to understand some of the more typical star schema models you may be dealing with. Even though it's got data warehouse in the name, star schemas are also applicable. That book describes star schemas more generally, which kind of applies just equally well to Power BI. There's probably also, I would say, another book by the Italians at SQL BI, so Marco Russo and Alberto Ferrari. They have a book, I think the name was Analyzing Data in Power BI. It's got an orange cover on it. It's as a printout book, it's actually fairly slim. It's only maybe 150 pages, something like that. But it's also very useful for these kinds of modeling ideas around knowing what belongs in a fact, what belongs in mention, how to model things. So those are probably the two go-to resources that I'd be recommending as far as books for developing star schemas there.
Thank you very much, Sam. Okay, another question. Does this automated approach also work if you have more than one flat table import to? Say I have data from 2 different years on 2 separate Excel files.
Yeah, that's an interesting question. So it would probably depend on how those 2 separate files coexist. So if in that example you've got data from 2 different years within different files, well, what you might need to do before applying this function is you need to make sure that you've got a single flat table to describe your whole data set. So what that would probably mean is appending the 2 different years into a single table, and then using that as what we've got here as a flat table to run in the function here. So that's if you've got 2 separate files that describe the same schema, but just over, say, different time periods. Maybe it's over, maybe it's partitioned by different stores or products. Like that's another scenario you might deal with there. The other scenario might be if you're dealing with flat tables where they describe different business activities or they come from different sources. And that's where you probably have to do a fair bit of trickery, where if you're going down the path of trying to conform those 2 flat tables into a single flat table to use in this function, you're probably over-engineering things a bit, and it's almost a little bit like trying to fit a square peg in a round hole. And I'd probably say at that point you'd want to think about stepping back and figuring out how to conform things a bit clearer way. I dare say you may be able to do this with this function, but you'd probably have to do like outer joins between the 2 files, and it may not be as performant. Like the other thing I'll flag with this as well is that this works well for small files, but if you're dealing with files with millions or tens of millions of records, you're going to have a real performance issue here. So when you're developing things out, you can always filter this down to the top 1,000 rows, and then as you're going, just verify that it's not going to time out as you go about things. But these kinds of approaches, again, Power Query on your desktop isn't necessarily designed for large scale operations. At that point, you're maybe better off with dealing with sturdier tools like Spark in Python or data pipelines within the Data Factory experience of Microsoft Fabric. But for smaller scale things, this should still have you covered.
Thank you for your answer, Sam. Pranam, do you have any other questions for Sam or any other person? Okay.
I think we're all covered.
I'll take that as a no. Okay. Okay. All right. Thank you. All right. Thank you very much, Sam. That was a very insightful and interesting session. I personally enjoyed it and I gained a few things. So just to bit a little bit more into your time, I would like to ask a question just for the whole community to just gain something from. So I will just put it as a 2-in-1 question. You are indeed a Power BI guru, and it would be very interesting for you to share your journey, or what's motivated you, or how you started your old data journey, and also the insights from your journey, and the advice you can give those who are just starting the journey, or those who are looking to upskill the journey. Sorry, upskill their those looking to upskill in their journey. Yeah, so I think those are the two questions.
Yeah, no, it's a good one. So I suppose my journey in the data analytics space started 6 or 7 years ago. I'd started more in like an analyst role where I was initially starting working with tools like Power BI, and I found as I was working with them and doing consulting as part of that role that it was actually quite fun and curious to learn about Power BI. So I honestly, even from that early point, I bought a lot of books related to Power BI, like some of the ones that I mentioned earlier. And as I was going through that and working, using Power BI at work, learning about things through those various resources, it kind of got me excited to actually use Power BI. So I'd often get to the point where I'd be using Power BI on the weekends for little learning projects there. So I've got some of those kinds of projects published up on my portfolio, my website there as well, which you're welcome to have a look at as well. But usually it's a matter of finding a data set for something that you're curious to analyze, or maybe you want to try out a particular technique, just getting some sample data, playing around with it and building things out. I think I built some stuff in the past around some, like I've tried to do things like learning about cohort analysis and some customer analytics, and I built out some sample reports that I think a couple of years ago I actually presented for this meetup group. So usually having some personal projects you want to try and learn from and do things to, I guess, fill in any gaps that you have, that's usually the way to do things. And yeah, I'd say that's probably that's what I'd be suggesting. If you're interested in this stuff, you want to learn about it, don't just isolate yourself to just doing things in your 9 to 5, but also think about, okay, what are some blogs I could read or some books that I could read? You know, you don't have to spend all your waking hours obsessing over it, but spending a few hours here and there can really add up in the long term. So that's what I'd probably say was key to my journey there.
Yeah, that's quite interesting. So something I can deduce from what you said is, okay, aside from reading books and just learning things, so I think one major thing is also the hands-on experience, working on projects and just exploring and playing with data sets just to get better. So thank you very much once again, Sam. We are really grateful to have you on our session. So just in case you have anyone who would love to or who has someone who wants to present or wants to present probably in our subsequent sessions. So I would actually be posting a form where you can fill, and also just the feedback form has already been posted in the comment section. You can just fill it and just let us know how we can do better. And also, the recording of the part of this session is going to be posted in our YouTube channel shortly, maybe tomorrow, hopefully. And you can also connect with Sam on LinkedIn. I've posted his link earlier, and let me just do that again. You can also learn from Sam from his blog post at apexinsights.net. Yeah, so thank you everyone. Thank you, Sam. We are really grateful. And we hope to see you more on our sessions later in the future. Thank you everyone for joining. So I'll be ending the session. Yeah, thank you.
Thanks, Kim. Thanks, everyone.